We have a logarithm, a nested logarithm expression that's a lot easier than it looks actually. And these bases are sort of arbitrary here, but log base 2 of x, and I'm going to leave out the x. I use parentheses down here just for readability. But log base 2 of x, or any base greater than 1 of x, has this general shape, and that's because it's the inverse of an exponential function. So right here, it's going to pass through the point 1, 0. That's because any number raised to the 0 power is 1. Okay, and since the logarithm function is the inverse of the exponential function, that's why this holds. Now let me draw this. Okay, so again, I'm calling this log base 2. I'm not going to go to any special trouble. You know, they all look about the same. Some of them are steeper, some of them are not so steep. But notice here that log base 2 of x is always strictly greater than 0, just like any other logarithm function. All right, it's well, it's not, that's not true. The domain, okay, the domain of this function. Let me erase that real quick. It's defined on the interval. It's defined on the interval 0 to infinity. Okay. And just the shape of the graph and think about how it relates to the exponential function makes it clear that the domain of this function is the interval 0 to infinity, non-inclusive. Okay. Now, so the next big idea right here is we must force the input. Here the input is x. Here the input's far more complicated. It's log base 7, log base 3, log base 8 of the quantity n cubed plus n squared plus 261. So this simple observation right here just extends to this, where we have to force the input to log base 2, which is this expression right here that I just stated. Now the next thing we're going to take advantage of is if you have b, any arbitrary base, raised to the log base b of x. Again, this is just a statement of the fact that these two functions are inverses of each other. Okay, this is of x. This is equal to x. They undo the work of each other, so to speak. Okay, b to the log base b of x is just x. All right, so we're going to successively exponentiate here. So what we did is this part right here just really, and I'll write this just to the right, just so, because I'm leaving a little bit out here. This is 7 to the 0 power, right? Anything to the 0 power. So we exponentiated this expression, and it stripped away this logarithm. Okay. Now, in a similar fashion, we exponentiate this 1 using the base 3. So this actually, I'll write this 3 to the first just for emphasis, right? Okay. And then finally, we exponentiate base 8 to get this statement right here. Okay, this is 8 cubed. Now 8 cubed is 8 times 8 times 8. 8 times 8 is 64. 8 times 64 is 512. Okay, so this is 512. All right. And again, this is a greater than statement. The greater than just carries on, just treating it like an equality. Now right here, what we get is n cubed plus n squared. In order for this to be defined, okay, has to be greater than 512 minus 261. Well, 512 minus 261 is 251. And I left out that step. I just did if you subtract 261 from 512, you get 251. That's an easy calculation. Okay. Now, so again, we're looking for the smallest positive integer, or the smallest natural number that is greater than this number, and it's very easy to check that for n equals 6. Again, you can just check along, but n equals 6 gives us 252 right here, which is certainly greater than 251. That constant was sort of designed just to make it close. It's not necessary though. All right. Now, y'all, just so this is our answer, n equals 6 is the smallest natural number such that this original expression up here, I'll just write it here just for the sake of, okay, so the smallest natural number n such that this expression is defined is n equals 6. Okay, that is our answer. Now, something that's kind of interesting for those of you who like to mess around with Wolfram Alpha, you know, the AI type of math engine. If you substitute n equals 5, which is the greatest integer that's less than 6, okay, you actually would get complex solutions, complex answer, shall we call it that? And so now I couldn't do that by hand, of course, but I did check. If you plug n equals 6 into this expression, you get some negative integer. But if you not a negative integer, a negative real number, I think. Okay, but if you substitute n equals 5 in here, you actually get complex solutions. Okay, complex solution. In any other integer, or actually any real number less than 251 would result, right? Less than or equal to 251, I suppose. Yep, would result in complex solutions. And again, that's a tough thing to check by hand. I don't even know anything about complex logarithms. Okay, so I'm just trusting the technology, but that is what I use to verify that this answer is correct. N equals 6 is the answer. Okay, till next time.